AP Calculus AB, Unit 9, Day 8B. It's another review assignment, multiple choice for most of it. These are the answers at the top. So go ahead and check your answers real quick. Pause the video if you need to. And then we're going to do these problems. So assuming you guys have checked them. Let's see. So these first ones, some practice with Riemann sums. So it says estimate with 3 subdivisions of equal width. Okay, so all of these. And I guess we're going to make our own table of values. So it's going to be 0 to 6, 3 subdivisions. Be 2 each, 2, 0, 2, 4, 6. For midpoint, we're going to have to do the ones in between. So we might do those two, 1, 3, 5. So we're going to plug these into f of x, actual function there. So you plug 0 in, you get 2. Plug 1 in, you get 1. Plug 2 in, you get 4 minus, you get 2. Plug 3 in, you get 9 minus 6 is 3. Plus 2 is 5. Plug 4 in, you get 16 minus 8 is 8. Plus 2 is 10. 25 minus 10 is 15. Plus 2 is 17. 36 minus 12 is 24. Plus 2 is 26. So those are the values we're going to be using. And I would draw a picture for each of these. 0, 2, 4, 6. Equal subdivisions. 3. I mean, all these are going to kind of have the same, So 0, 2, 2, 2, 4, 10, 6, 26. It's the left end, so we're using the left side. So we're not going to use that last one. The bases are 2 each. So the integral of 0 to 6 of x squared minus 2x plus 2 dx is approximately base times height, 2 times 2, plus base times height, 2 times 2, plus base times height, 2 times 10. So that's going to be 4 plus 20. So our final answer is going to be 0 to 6 of x squared minus 2x plus 2 dx is approximately 28. Which I guess matches answer D. Okay, next one. 0, 2, 4, 6. Same values, 2, 2, 10, 26. But it's the right end, so we're using the right edge. We're not going to use that one. Bases are 2 still. So the integral of 0 to 6 of x squared minus 2x plus 2 parentheses dx is approximately base times height, 2 times 2, base times height, 2 times 10, base times height, 2 times 26. And that's going to give us 4 plus 20 plus 52. So the integral of 0 to 6 of x squared minus 2x plus 2 parentheses dx is approximately 76. So that is going to match answer A. Okay, next one's midpoint. 0, 2, 4, 6, but we need the halfway points. 1, 3, and 5. We've got to use those as the height. So 1 is 1, 3 is 5, and 5 is 17. It's 3 rectangles. We use the middle as the height. Bases are still 2 each. So the integral of 0 to 6 of x squared minus 2x plus 2 parentheses dx is approximately 2 times 1, 2 times 5, and 2 times 17. So that's going to be 2 plus 10 plus 34. So the integral of 0 to 6 x squared minus 2x plus 2 dx is approximately 46, which matches answer B. All right, trapezoids, finish it off. 0, 2, 4, 6. So use the values from the beginning. 2, 2, 10, 26. I'm going to connect the endpoints. You might be like, oh, that's not a parallelogram. Technically, it's not, but we could use this formula, still get the area of it. It's triangle or rectangle. Okay. These things at the bottom are now going to be the heights of each parallelogram because they're sideways. So 0 to 6, x squared is 2x plus 2 dx is approximately average of the bases, 2 plus 2 over 2 times the height, 2. Average of the bases, 2 plus 10 over 2 times the height, 2 plus 10 plus 26 over 2 times 2. All the 2's cancel. So we get 4 plus 12 plus 36 equals 52. So 0 to 6 of x squared minus 2x plus 2 dx is approximately 52, which matches answer C. These are all different approximations for the same function at the same slices. So you can see they kind of vary quite a bit. The midpoints and the trapezoids are probably closer to the right answer with a limited amount of slices like here. Okay. Next problem, absolute values. So we can do these problems 3 different ways. So I'll try and show you all 3 different ways. First way is with geometry because it's linear. So -3 slope of 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. But then the absolute value flips the negative part up. So that's the actual graph. And we want to go from 2, so that little part, to 4, so that little part. 2 little tiny triangles. So a little triangle plus another little right triangle, 1/2 base times height plus 1/2 base times height. I think they're congruent triangles, right? So it's going to be 1/2 plus 1/2 is 1. The answer is A. So that's one way to do it. Another way is with that table. Another way is just sort of like the normal way. Now with the table, you want to find the 0. So we're going to integrate x minus 3 just with parentheses. So it's going to be x squared over 2 minus 3x plus c. We don't really need plus c. Now the 0 here is that x equals 3. So we got to break it up at 3, which also matches our graph where we had to break it up at 3. We plug 2 in here. We're going to get 2 minus 6 equals -4. Plug 3 in, you're going to get 9/2 minus 9, which is going to be -9/2. And plug 4 in, you're going to get 16 over 2 is 8, minus 12 is -4. Now we could change these to -8/2. And we're going to find the distance between these. So that's 1/2. And that's 1/2. And if you add those together, guess what you get? 1. Same answer. Or we do a line check, put the 0 in here, test a value, x equals 4, positive, negative. I'm going to rewrite it. You're going to go 2 to 3, drop the absolute values. And we're going to go 3 to 4, drop the absolute values. And the negative part, we're going to fix with an extra negative. The positive part just stays the same. So this is the way you can do it. And we're going to do the same work we did here, but it's going to be multiple times. So negative x squared over 2 minus 3x. That's exactly what we got up there. I'm going to plug in 2 and 3 just like we did here. X squared over 2 minus 3x. Again, I'm going to plug 3 in again. I'm going to plug 4 in like we did up there. So you're doing the same work, but more of it. So if you plug 3 in, you get 9 halves minus 9 minus 2 minus 6 plus plug 4 and 16 over 2 is 8 minus 12 minus 9 halves minus 9. So now we just got to clean all that up. So it's going to be negative 4. So, and that's going to be negative 9 halves. So it's going to end up positive 9 halves minus 4 plus is going to be negative 4 plus 9 is 5 minus 9 halves. So the 9 halves are going to cancel. Negative 4 plus 5 is 1. Same answer. So it's up to you. On a test, I'll let you do it any of those ways. Here's another one we could do with a graph. So lines at 2, up 1, over 1, up 1, over 1, up 1, over 1, down 1, left 1, down 1, left 1, down 1, left 1. And then the absolute value flips it up. So it's going to go like that. And we want negative 3 to positive 3. So it's 2 triangles. So it's going to be little triangle plus a big triangle. So 1/2 base times height plus 1/2 base times height. So it's going to be 1/2. The first one has a base of 1 and a height of 1. Plus the next one has a base of 5 and a height of, I think, also 5 because that's a slope 1. So that's going to be 1/2 plus 25 halves is 26 halves is 13. Okay, so it's one way to do it. We could do a table. You want to find the zeros, negative 2. So you have to go negative 3, negative 2, and 3. And we'll plug them into the integral of x plus 2 without the absolute value. So x squared over 2 plus 2x plus c. Don't need plus c. We're breaking it up in negative 2 just like we had to in the pictures. And no matter what, you're breaking it up at the same place. So that's going to be positive 9 halves minus 6. So it'd be minus 12 halves. So it's going to be negative 3 halves. Negative 2 is going to be positive 2 minus 4. So it's going to be negative 2 or negative 4 halves. 3 is going to be 9 halves plus 6. So it's going to be 21 halves. And then you can find the distance between these is 1/2. The distance between these is 25 halves. And you add those together, 1/2 plus 25 halves equals 26 halves equals 13. Same answer. Or you can do line check, plug negative 2 on there, test a value, like x equals 0, positive, negative. You rewrite it, negative 3 to negative 2, drop the absolute values. And then negative 2 to positive 3, drop the absolute values. And the negative part, you got to fix it with an extra negative in front, force it to be positive. So then you're going to get x squared over 2 plus 2x. Don't forget the extra negative. And x squared over 2 plus 2x. And then we're going to plug in the answers. So negative 2 squared is 4, over 2 is 2, minus 4, minus, I'm going to plug in negative 3, it's going to be positive 9 halves, minus 6, plus, you can plug 3 in, it's going to be 9 halves, plus 6, minus plug negative 2 in, you're going to get a 2 minus 4. Now you just got to carefully get through all of that. And that's one of the benefits of the table is you're not doing so much stuff repetitively. I think it's also kind of easier to do the work in the end, but I mean, you could do this. So that's going to be negative 2. It's going to be what? 4 minus 9 halves. This is going to be negative 2. So that's going to be 9 halves plus 8. So distribute that. You get 9 halves, 18 halves is 9, minus 4 plus 8 is 13. Same answer. Okay, next one. Can't do this one geometrically because it's not linear. So you go straight to the table. Now you're going to have to find the zeros for the table or the other method. So t equals 0, t equals 2. I don't think you really need to do a line check unless you're going to be getting like weird irrational answers like from sine. Then line check could be good for the table. But I think we pull it off without it here. 3t squared minus 6t dt. So we're going to get 3t cubed over 3 minus 6t squared over 2 plus c. We're going to plug in 0, 2, and 4. Plug 0 in here, you get 0. Plug 2 in, you're going to get 8. Minus 12 is negative 4. You plug 4 in, you're going to get 64 minus 48 is 16. The distance is 4. The distance is 20. Your answer is going to be 4 plus 20 is 24. So that's using the table, as long as you understand how to use it. And realize that you know how to do it without the table, and just realize this is streamlining it for you. Because the other way is you can do a line check, 0, 2, test a value, x equals 3. It's going to be positive, negative, positive. So this is telling you you're going to have to break it up. You have to do 0 to 2 of 3t squared minus 6t dt. And you're going to have to do 2 to 4 of 3t squared minus 6t dt. And the negative part is going to have to get fixed with an extra negative in front. The other part just can stay positive. So we're going to get negative 3t cubed over 3 minus 6t squared over 2. Now the antiderivatives are going to be the same for both of these. So take advantage of that. T cubed minus 3t squared. 2 to 4. And then we got to start plugging things in carefully. Plug 2 in, you're going to get 8 minus 12 minus 0 minus 0. And here you're going to get 64 minus 48 minus 8 minus 12. So this is going to be negative 4, which is going to give you positive 4. If you do all of 1, it should end up positive. Like that's the point. That's why we fix it with a negative. This is going to be 16 plus 4 is 20. And then we get 24. So it's up to you. Either way, I'm showing you both ways. Okay, displacement and distance. These are going to involve absolute values, so you could take advantage of the things we've been doing to help you. You can make a table and do the whole problem for it. You have velocity, so displacement is the integral of velocity from 0 to 3, which is going to give you s3 minus s0 if you have the position function, and that's super easy. And this is going to be the integral of speed. So that's going to be the integral of the absolute value of 3t squared minus 6t dt from 0 to 3. So both of these are going to involve the integral of the same thing. So the table, you would want to find the zeros. So t equals 0 and 2. So you got to break it up 0, 2, and 3. And then we're going to integrate velocity without the absolute values. It's going to be 3t cubed over 3 minus 6t squared over 2 plus c. Don't need plus c. So we plug 0 in here, we get 0. Plug 2 in, we get 8 minus 12 is negative 4. Plug 3 in, 27 minus 27 is 0. So displacement is going to be the last one minus the first one, which is going to give you 0. And distance is going to be the distance between these, forced to be positive, and you're going to get 8. So that's kind of the streamlined approach. Otherwise, you could do the work that these are telling you to do. So you could integrate the 3t squared minus 6t dt from 0 to 3 to get displacement. It's going to be 3t cubed over 3 minus 6t squared over 2. And you plug in 0 to 3. So if you plug 3 in, you're going to get 27 minus 27. Plug 0 in, you get 0 minus 0. And you're going to get 0. Same answer. Distance, you could break this up. Say, all right, we're going to do 0 to 2 of 3t squared minus 6t dt. And then we're going to do 2 to 3 of 3t squared minus 6t dt. And then we do a line check. 0 and 2. Test a point, like t equals 3. Positive, negative, positive. This is the part you got to fix. So then integrate it, 3t cubed over 3 minus 6t squared over 2. 0 to 2. They're the same antiderivative, so it's going to be, t cubed is 3t squared, 2 to 3. We got to carefully plug these values in, so it's going to be 8 minus 12 and 0 minus 0. And this one's going to be 27 minus 27 minus 8 minus 12. It's going to be 0. It's going to be 0. So we get negative 4, which is positive 4. And then we're going to get a plus negative 4. So that's positive 4. And we're going to get 8 for the distance. That table thing's pretty slick. I mean, I use that table to do, so you could do this, or you do all of that. Like, I don't know which way you want to do it. Okay, mean value theorem. We found a new mean value theorem, not for derivatives. It works for derivatives though, but the derivative one's still worth it because it works. It's a pretty nice one. It's a derivative. So average value of a function, those are the endpoints. It says they're actually giving the average value is 12. So they're giving you f average. And they want to know what the integral of f is. Well, that's the way we find f average. So let's act like we're trying to find f average. We find the area under the curve and smooth it out like a rectangle whose height is what we're looking for. So we divide by the base of the rectangle. That's how I remember it and get right every single time. And I didn't always do that. So we don't actually have the function, but they did tell us the answer was 12, right? So now we could solve for this by multiplying both sides by 4. And so the integral of 3 to 7 of f of x dx equals 48. So kind of using it backwards. Okay, next one, average value is what? Okay, well, if you want to find f average, you need to integrate the function, which I'm going to go ahead and write as a rational exponent. And from 0 to 9, and then you divide by the base. Smooth out like a rectangle, divide by the base of the rectangle, get the height of the rectangle. Now, you guys need to be careful with this. This is a U substitution issue. If you want, there's going to be an extra 3 that jumps out that you don't want here, so you're going to have to put a 1/3 in front. Now, I'm going to skip the whole U substitution thing and say, okay, well, this is going to be 3x to 3 halves divided by the new exponent, but I also need an extra 1/3 because of the extra 3 that's going to pop out. So we're going to get 1/9, and that's going to be what, 2/9. And if we plug 9 here is 27. I guess we should have 27 3 halves minus 2/9, and we plug 0 in. That term's going to go away. So what's this going to be? It's going to be 2 over 81. The square root of 27 And then we're going to cube it. Oh my gosh. You know what I'm going to do? I'm going to think of it, do the cube first. And if you do the square root of that, we can take pairs out, right? So we get 27 on the outside. And then we have square root of 27, which we can take a 9 out. So we get another 3, and there's square root of 3 left. 3 times 27 is 81. So we get 2 root 3. A little messy algebra there. Number 8, average value of the function, closed interval is what? Those are your endpoints. So f average, okay, remember we find the area under the curve, sine x dx, 0 to pi over 2. And we smooth it out like a rectangle, whose height is our average height. Divide by the base. And that's how we get our answer. So this is going to end up being 2 over pi. It's going to be negative cosine, antiderivative 0 to pi over 2. So we get negative cosine of pi over 2 minus negative cosine of 0. Cosine pi over 2 is 0. Cosine 0 is 1. But there's a negative, so it's going to be positive. It's going to be 2 over pi. There we go. Okay, next one, average value of the function. So here's another one, f average equals, I don't memorize this as a formula. I say, okay, idea, I want to integrate the function to get the area underneath it. And then I want to smooth out like a rectangle whose height is the f average. So I'm going to divide by the base of the rectangle, which should come out positive, right? You always want to do bigger x minus smaller x. Okay, so that's going to be 1/4. Antiderivative is going to be sine 1/2 x, but an extra 1/2 is going to pop out that I don't want. So I need to divide by 1/2 or multiply by 2. You could use substitution to get that. There's going to be extra 2 in front, if you don't feel comfortable with doing that in your head. So 2 sine 0 minus 2 sine negative 2. Okay, now sine of 0 is 0, right? So this is negative 1/2 sine of negative 2. But you look at all these answers, and none of them have negative 2's. But then you remember that sine is an odd function, has odd symmetry. That means if you plug in the negative, you get the same thing as the positive, but the opposite sign. So this is the same thing as negative 1/2 times negative sine of positive 2. And so then you get positive 1/2 sine of 2, which is the same thing as what we got, but actually on your list. So you got to remember your properties of trig. Okay, position of particle on x-axis, average velocity. Now, average velocity is a derivative, so I'm going to totally, I feel like it's worth it to, it says that the position is this, so that's your position. So it's going to be SE minus S1 over E over 1. I mean, you could use that new mean value theorem that works for any function, including velocity or position, whatever. But you're going to be doing a lot of extra work and undoing it. This is quicker. This is eventually what you're going to get to. So natural log E is 1 minus natural log of 1 is 0. So we get 1 over E minus 1, which you cannot break up. Otherwise, you could say, oh, well, let's find velocity. Velocity is 1 over t, and let's do average velocity is going to be the integral of velocity from 1 to e, divide by the base, base of the rectangle. It's going to be 1 over e minus 1, integral of 1 over t, which is going to give you natural log of the absolute value of t. Essentially, you took the derivative position to get velocity so that you could integrate velocity and get back to the position. You're doing work to undo it. That's 1, that's 0. Same answer, lots more work. Okay. 11. Which of the functions given below has an average mean value of 0 from negative a to a when a is greater than 0? So think about this. Just graph quick sign. If you go from a to negative a, it's going to be the area. Remember the area underside? Well, the area is going to be 0 for an odd function, right? So you're going to get a 0 mean value theorem. So I'm thinking it's A. Cosine, that's not going to happen every time. I mean, there might be one that it does, but usually it's not going to be 0. Square root of x, well, it doesn't even exist over here at negative a, so that just doesn't make sense. Absolute value would look like that. Go from negative a to a, that's not going to be 0. X, this one's just some kind of like quartic, it's not going to do it. So, anyways, you could check these all on graphing calculator, I guess. Just plug some different values in. Okay, fundamental theorem calculus part 1. If I give you the integral of a derivative, you say, oh yeah, well, if I integrate the derivative, this is the fundamental theorem calculus part 1, I get the original function. If I know 2 and I want 10, let's put those in the limits, because then I get f of 10 minus f of 2, and I want f of 10. So now, if I just add this to the other side, I get f of 10 equals f of 2 plus the integral of 2 to 10 of f prime of x dx. And f of 2 is 30, and the integral from 2 to 10 of f prime of x is 18. So I get 48. Nice, right? Now here's another one. This is graphing calculator. Same idea. If I integrate f prime of x dx, I get the original function. So if I have 2 and I want 10, I'm going to go 2 to 10. I get f of 10 minus f of 2. I want f of 10, so I'm going to add this to the other side. I'm going to get f of 10 equals f of 2 plus the integral of 2 to 10 of f prime of x dx. And then f of 2 is 7. Now, this time, we're actually going to integrate a function, x natural log of x. The only problem is that you guys know how to integrate this. And even if you did, it's going to be way faster to do it on a graphing calculator. So let's do it on a graphing calculator. It's going to be 7 plus math 9 x natural log x, comma 2, comma 10. It's that quick. Done. Done. 96.742, 3 decimal accuracy, rounded or truncated. I like to truncate because it's hard to mess up, but if you did round this one, this would be the correct answer, rounded, if you round it correctly. You can mess up rounded. You can't mess up truncating. All right, 13. Hey, same idea. I'm giving you information about f prime, but instead of just giving you the number or giving you a function that you can use a graphic calculator, I'm giving you a graph of f prime. It's the same idea. If I integrate f prime, get the area under the curve from the graph that they gave me from 8 to 12, because then I could get f of 12 minus f of 8. I want f of 8. So I'm going to add to the other side, subtract this, get f of 8 equals f of 12 minus 8 to 12 of f prime of x dx. This is really good stuff to write down. This shows me you understand the basic idea. So if you mess up the area, but you at least have this written down correctly, I'm going to give you tons of credit. But if you mess up the area and hadn't written this down, and I don't know why, or I don't even know if you mess up the area, because you're going to lose a lot more points. So f12 is 100 minus, we've got to find the area from 8 to 12. So that's a trapezoid. I mean, I personally do average of the bases, which is going to be 4 and 2. Average of the base is 2 plus 4 over 2 times the height is 8. 4 times 6 is 24. So the area of that is 24. So your answer for f of 8 is 76. You could also cut this into a rectangle and triangle, and you could do 2 times 8 is 16. 1 half 4. Now 1 half 2 is 1 times 8 is 8. Add those together, and you get 24, but you had to do a couple extra steps. Fundamental theorem of calculus part 2. I love these. I think they're super quick and easy. It says derivative undoes the integral, but then you got to plug the limits in. 1 plus 0 squared minus 1 over 1 plus x squared. But then you also need to multiply by the derivative of what you just plugged in. Derivative 0 is 0. Derivative x is 1. That drops out. We get negative 1 over 1 plus x squared. Quick and easy. Next one, derivative undoes the integral. Then we plug limit in. Then we got to remember multiply by the derivative of what we did. That's chain rule. So we're going to get e to the 2x plus 2 times 2x. And we got to multiply by the derivative of what we plugged in. Even though it shows up in more than one spot, you only multiply by the derivative once. Minus e to the 0 plus 2 times 0, which is not 0 itself. It's 1, but you're going to multiply by the derivative of what you plugged in. Derivative 0, 0, that drops out. So we get 2e to the 2x plus 8x. I hope you guys feel good at those problems. There should be some quick points. Correct. Got a couple more. Okay, derivative is the integral, but then you got to plug the limits in. So we're going to get sine of, and I always like to put these in parentheses first so I don't minus, because that's what we want to take a derivative of. X cubed is 3x squared, not x is 6. Sine of x squared. Now, it's not the derivative of x squared, it's the derivative of x, which is 1. So it's going to be 3x squared sine of x to the 6th minus sine of x squared, simplified for the final answer. 3x squared sine x to the 6th. So that looks like answer C. Just be careful, show your work. These are quick problems, but you don't want to mess them up. Now this one's kind of weird. We're integrating the derivative. So we've done that before, right? I mean, that's fundamental theorem of calculus. You get the original function, and then you plug the limits in. So this is kind of a, if you integrate f prime, you get f, right? That's the same thing as what we're having here. And so if you plug 4 in, you get 3 times 4 squared plus 2 times 4 minus 1 minus 3 times 2 squared plus 2 times 2 minus 1. So we get 3 times 16 is 48 plus 8 minus 1. 12 plus 4 minus 1. 56, 55, 16, 15, 40. Now, we didn't have to do it that way. You could have actually taken the derivative of this, right? You could say, okay, well, that's going to be 6t plus 2, and then integrated it, and you get 6t squared over 2 plus 2t plus c, which is interesting because that minus 1 is the c value. If you do it this way, you lose that. But it doesn't matter because both of them have the c. Both had the minus 1, so it ended up canceling out anyways. You get the same answer this way. 3 times 4 squared plus 2 times 4. We don't need to put the c in a definite interval. Minus 3 times 2 squared plus 2 times 2. So that's going to be 3 times 16 is 48 plus 8. 12 plus 4, 56, minus 16 is 40. So we lost those minus 1s, but since they both have it as a plus c, it didn't really matter. I don't really know which one was quicker than the other. 19, Roman numeral problems. It's like 3 problems 1, and you got to get them all right to get the whole problem right. Let f be a differentiable function, which the following must be true. if you take the derivative of the interval, do you get f of x? No, you get f of 3 minus f of 0, and then you got to multiply by the derivative of what's inside, which is 0, which also makes sense that we're going to get 0 because this is going to give you a number, and the derivative number should be 0, so that one's for sure out. Next one says if you integrate the derivative, you're going to get f of x. No, because then you have to do minus f of 3 also. You got to plug limits in, so that one's out. That's what it should be. And, on true false problem on my test, I need to have work to back it up. So I'm showing you the work right now. So this one says if you take a derivative of the integral, plug in the function, which is true, but then you also got to plug in 3, but then you got to also multiply by the derivative of what's in front, which means that drops out, and you do get f of x. In the end, you do get f of x. So 3 only. 3 is true. Okay, integration by use substitution. Just, I guess, a little review here. This is the use substitution you want to do. But these are kind of interesting because the answers all have u's in them, which there's a little thing in there that's going to mess people up. So if we do this, now this has some other issues too. du is going to be 2x dx. And you're like, what? Well, I don't want the 2. Okay, that's fine. But then I only have x dx and there's x squared here still. Okay, well, guess what? You could, this is one of those problems where x squared equals u minus 1. So this one's kind of weird. You're going to say, okay, you're going to do a u minus 1 and then a du over u. Now, you might start looking at these answers and say, okay, they all have like this 2. I guess we could rewrite it like this and move the 2 inside because a lot of them have that. So you might say, oh, and then like 0 to 2, it's going to be b. And because look, you left the limits the same. Those were x values. So if you're going to pick an answer with all u's, that means the limits have to also be changed to u. It's super easy to do. You just plug these x's into the, if x equals 0, then u is going to equal 1. If x equals 2, then u is going to equal 5. That's the one you're looking for, A. Watch out for that. You got to change the limits to u. If you're going to pick answers with u's in them, the limits have to be changed also. So that might be an issue over here too. du equals negative 2x dx. Perfect. This one's less weird than the other. So you can get negative 1/2 in front, and that's going to be the square root of u du. So same issue again, but we don't want to pick the one that's 0 to 3. Okay, we want to pick the one. We want to change them to u limits. These are x values originally, and it looks like we're going to leave everything in terms of u, which means we've got to get the limits in u. So if u equals 25 minus x squared and x equals 0, then u equals 25, and this one's going to be 16. So then you start looking for this answer. And you're like, well, there's only one with the negative 1/2. It's got to be that, but that one has the wrong limits. What? How? Where is that? You start looking, you're like, oh, well, this one is 25, 16, but wait, this has 16, 25. Oh, if I could flip these limits, right? I'm allowed to do that. And if I do that, I also need to make an extra negative in front, which makes it positive. That means that this is also another possible answer, which matches D. So there's a couple of interesting problems at the end. I mean, kind of review stuff from previous units, but good stuff. Okay, that's it.